Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother Joel. We're here to hopefully show you how to approach studying for the SAT and also doing the SAT problems. We are now going through the Khan Academy questions, but on the harder side. Khan Academy offers questions on the 40 topics that are on the SAT, and each topic they give you about 20 questions. We are at the 16th question. Oh, Seth likes when I use a smaller line there. We are at the 16th question. See how there are four little things there, and that tells you what level you're at. Okay, so we're starting with question 16. If this question is too challenging for you, go back to Khan and do the other 15. Although actually, even if it's not challenging for you, go back and do the other 15, because the more problems you do, the more mistakes you make, the more you become self-aware, and the better you'll do on the test. Okay, anyway, here we go. So please read the question and pause it, and we'll do it. Okay, two football players are located at points A and B in a rectangular football field as shown. Point A is located 50 yards from the east edge, and 25 yards from the south edge. Thank you. So that assumes this is north. I guess you always have to assume that's north, right? Thanks, Seth. Point B is located. Does it really matter if they draw the picture anyway? And point B is located.
My approach.
Wait.
My approach
I haven't read the question
is to very briefly check that the picture is consistent with the words,
right?
And then work from the picture.
Point B is located. Okay, right. Okay? That makes sense. So it seems like the picture is consistent with the words, doesn't it?
Yeah.
Yeah. So then, now of course you're in Khan and you're told that this is a right triangle word problem, so you know you're gonna have to use right triangles. On the SAT, they're not going to tell you that, hey, this is a triangle word problem. But
so what do you have to review? What is the thing that you would review that bears upon this problem?
Right. It turns there's something called the Pythagorean Theorem, which relates the three sides of a right triangle. And the Pythagorean Theorem is a squared plus b squared is c squared. It is highly likely that everyone who's plans to take the SAT will have heard of the Pythagorean Theorem. It is a relationship which relates the three sides of a right triangle.
The lengths of the three sides.
The lengths of the three sides of a right triangle, not the angles, the lengths. And you have to, I always say, when in doubt, in geometry, drop a perpendicular, and all radii are equal in a circle. Well, that doesn't apply here about the radii, but when in doubt, drop a perpendicular, because spam, can you believe it? Because it creates a right triangle, and then you can use the Pythagorean theorem. So then, the new SAT coming in the winter of 2024 is all calculator. Plus, look at this, nearest tenth of a yard. So, of course, this is a calculator question. So then you just apply the Pythagorean theorem to this thing, but you have to make sure you know what's the hypotenuse. I always joke that the hypotenuse is the big shot, the royalty in the house. And you don't fool around with the hypotenuse. They give very much respect to the hypotenuse. And you first recognize what the hypotenuse is, which is this thing. And that is what they're asking for. By the way, that's also what they're asking for. They're asking for the distance between the 2 points. So we have to solve for the hypotenuse, right? It must be a right angle. That's right. Seth is putting all this good stuff in. So I talk too much. You want to finish it off, Seth?
Well, I'm writing down what it would be, what would be reviewed and is involved in the thinking. So given the lengths of the other two sides, to find the length of the hypotenuse.
Right.
How do you do that?
Yeah. Right.
You apply methods of solving equations. What is the fundamental method for solving equations? It's called converting the equation to an equivalent equation that isolates the variable you want to solve for.
Fine.
In this case, it's already done. The variable that you want to solve for is C.
Yep.
And the equation tells you right off some numerical fact that is critical about C.
Right.
That its square is equal to the square of the length of the square of the length of the other side, and the plus the square of the length of the other side.
Right.
Okay.
Right.
But the question is for the actual length and not the square. So
Right.
then another element of math is that if you have calculated some number, and you want what number would you square to get it, then you take the square root. And so the answer would be the square root of what I wrote in algebra, a squared plus b squared. So all you have to do is figure out what is a and what is b. Well, little a, the length of one side, is given right off in the problem. So that a is 25 yards. And in our calculation, we must remember to square it. But what is b? That's something you need to figure out. They don't tell you. They don't tell you b.
Yeah, you got to be
but
really careful.
They tell you the coordinates of the endpoints of b.
Right.
And they tell you the relevant coordinates, the east-west coordinates. So to get the length of b, you simply subtract.
Right.
So let's do subtracting. 50 minus 12. Now either use a calculator or do the arithmetic and get, let's see, 10 minus 2, carry the 1, 10, so we get a 10. 10 minus 2 is 8. After borrowing the 1, we have to keep track of our debt. So the 4 becomes a 5. The 5 becomes a 4. So this is what we have is 4 left, and subtract 1 and get 3. And so the answer is, so B is 38. We have to plug 38.
Okay, so let me do that in a calculator.
And then this is a calculator question.
So it's
where the intention of the designer is you will use your calculator.
Right. So I already know 25 squared is 625. Some people may know that already. And 38 squared, you need a calculator to be practical. You add 625 plus 1, 625 plus 1444 to get
1,444, also known as 1,440.
Right. You get 2069. You take the square root of 2069. You have to be careful to round to the right rounding.
Yeah. So
so we get 45.486. So carry it all. Now we need to the nearest tenth of the yard. So we have to, this 4 rounds up because this 8 is bigger than a 5. Is 5 or bigger. So the final answer, which I will write here, will be 45.5. And that's about it. It's clearly a calculated question. You have to be really careful not to use 12 or 50 as the B. It's very dangerous there. You have to be ready in geometry.
Well, it's not dangerous. It's mathematically wrong.
I know. But sometimes it's in geometry.
And it's you make a mistake in math.
Yeah.
How dangerous it is depends on what you're going to use the faulty answer for. If it's going to simply tell your friend, it's not dangerous at all.
Okay.
Right? It's actually it's not only not dangerous, it's beneficial. because then your friend will help you by teaching you that you were misled and that there's something for you to learn.
Right, right, right,
You
right.
know,
Good.
learning from mistakes is the better outcome of doing math.
Right, right, right. Absolutely. But remember, in geometry, it's so common that instead of being told that this side is a seven, you very often in geometry you'll have a situation where, let's say this side is a seven. They want you to calculate this side seven. They won't tell you it's seven. They'll tell you that this distance is 10, and then they'll tell you that this distance is 3, and then
Yeah.
you have to calculate the difference. So
So Joe, yeah, let's. We should. I want to share with the audience that you were trained and did some practice as an engineer. Is that correct?
absolutely,
Yeah.
absolutely.
Now, when you worked as an engineer, what did you do when you did mathematical calculations where a mistake would really be dangerous? How did you do math
Very well.
when?
First of all, very carefully, and also you work as a team, and everybody checks everybody else multiple times. And if I never, I guess I did work in the defense industry a little bit, but I didn't really understand what I was doing. But but if you are working on the defense industry, like on a real thing, like a lot of people do, it gets checked so many times. There's so many teams to check, double check, triple check, quadruple check. So yeah, I mean, you be careful the first time, but everybody checks each other, which is different, like on a test, because nobody's checking nobody, no other party, and you don't have 3 people, you don't have a team checking your work before you hand the paper. But yeah, that's how you do it in reality. Is everybody
Yeah,
checks each other. Plus, you're careful.
yeah,
You check
yeah,
your own work 3 times before you hand it to the other people to check.
yeah. Well, let me describe another difference between the practice of what you do when you solve problems with special cases that do math when it's on a job compared to when you do it in school. In school, the teachers give you math and other problems in order to teach you how to do them. The teacher does not care or rely upon the results that you get. The teacher is not paid to have his or her students do math problems so that she or he can get the answers and then use them for something where a mistake would be important.
Right.
And so the setup and the rules many the rules will demand that sometimes, and for some unfortunate people all the time, you have to do them all by yourself, and they don't give you much help except when, say, you ask for it and you say, I want to learn better how to do something.
Yeah.
Now it's completely opposite when math or is used in a job. In a job, you are working with other people. You're in a team, and the goal is to accomplish, actually make something work, make it work reliably, calculate information from data that is accurate. And so everybody helps everybody else to work efficiently and correctly, uh, and all that stuff. So people's attitude is not like a testing attitude where they are putting you on trial
Right.
when you take a test and making you compete with other people for getting high scores to get admission to colleges and stuff like that. But the goal is for everybody together to achieve common goals, and it feels very different.
Yeah, of course. Yeah. Okay, Seth, so right, in high school you are completely correct. We must say if you're going to be in graduate school and you're doing PhD work with a professor, or you're in master's and you're doing a thesis and you're helping a person in let's say university do work which will be published or which will be used, let's say, for medical research, then even though you're technically still in school because you're going for a master's or you're doing research, people do count on your results. But that's not high school. Okay, in high school you're almost never doing research that will be used for in another reason. But there are cases where in high school some kids do research which could be used for different purposes outside of just the class. But we're talking about a normal scholastic testing environment where Seth's completely. Seth, you're so philosophical today.
Yeah.
Yeah. Okay, so get away from the. We're done with the philosophy. I was going to say something also philosophical today, but you already stole the philosophy for the day, so we'll move that some other day. So why don't we see how they do it? They probably, the SAT people and the Khan Academy people probably do the problem in a very similar way to how we did it. Oh God, I forgot the answer. Oh no. Well, God. No, 45. 45.9? I think so. Or 45.8. God, I don't remember. Well, whatever.
Well, we should let's really make sure let's work to get it right, because otherwise we'll be forced to repeat another problem that's the same level of difficulty.
No,
if we give them the answer that agrees with their answer, we'll make progress to harder problems.
No, I don't think it works that way. I think no matter what, you move to question 2.
Okay.
No. But if you get like 4 questions wrong, if you get 4 out of 5 wrong, they don't bop you to the next level. They keep you at this level. But
all right.
So we could just. By the way, it's good. Let's see what happens when you answer the question potentially wrong. Okay, so let's say 45.9. Oh well, I don't think we got it right. I think it was 45.8.
Okay.
So now we can draw this triangle separately to obtain the lengths, right? Which is good. That's what we did. And we can apply the Pythagorean theorem as applied. We applied the. Oh, I said 45.9. It's 45.5. Yeah. Okay.
Yeah, 0.48.
Yeah, so it's 45. It's 45.5.
The decimal that begins with 0.48 and other numbers. Yeah, the 8/100ths is rounded up. 8/100ths is almost 10/100ths, which is 1/10.
Right. Yeah.
So it's 8/100ths is closer to 1/10 than it is to 0/10.
Yeah. So
we round it up, and so bringing up 1/10, we add the rounded tenth to the 4 to get a 5. Right. So
notice here they didn't expand out the numbers, but
when you use a calculator. Okay, another element of practicing for the SAT. Learn to use your calculator.
Yes.
So that you do not have to manually copy intermediate result numbers.
Right. That's a good point. So yes, when you're studying, doing these problems, do exactly what Seth said. type this directly in the calculator, or some calculators may have slightly different keystrokes. So in your calculator that you plan to take the SAT, which is generally the TI-84, but please talk to your guidance counselor to be sure to do that. But yes, when you start taking the digital SAT in January 2024, they will give you an on-screen calculator.
Uh-huh.
So you should practice with that on-screen calculator using the digital SAT practice stuff that the SAT people give you, so that you have practice using the calculator that they will be providing for you online. So because you don't want to fudge that, you don't want to fidget with the calculator the day of the SAT if that's the first time you ever saw their online calculator, or just bring
now, Joel. The digital SAT, will the students be permitted to use their own calculator?
Apparently, yes.
Okay.
Apparently, yes.
So you have your choice.
Yes, and maybe you should bring it just in case. Yeah.
Actually, it might be a better idea because you would have more practice.
Yes, absolutely.
Using your own calculator.
Yes, and I'm not sure whether the calculator they're going to give you is going to be a graphing calculator. You would think it would be, but
so graphing calculators are illegal for the SAT.
No, they aren't. No, the TI-84 is a graphing calculator.
They are legal.
Yeah, they are legal.
Okay.
Yeah, they are legal. Okay, everyone, I think we've done enough for today. Then have a great day. Please like us, dislike us, give us comments on our YouTube video, or email us at satmathquestionoftheday@gmail.com. Particularly if you have an SAT math question, please email us at satmathquestionoftheday@gmail.com. And Seth made an offer the other day, or maybe I put it in Seth's mouth, that if your teacher ever tells you to do something in math and does not justify why or how you do it, you know who to contact at satmathquestionoftheday@gmail.com, and we'd be more than happy to give a justification.
Well, when that happens, when you find something is taught or claimed to be, and you're not given a justification for it, actually, the really fun thing to do is to try to justify it yourself.
Of course.
And in elementary mathematical subjects, you're given math that is not all that hard, and so figuring out the justification is something that's possible for anybody, any student to do themselves.
Right.
But you may find it a little hard. You may not think of just what to do, and you might feel a little confused. That's because you're a beginner.
Right.
In that case, seek some advice on finding justifications. And one resource we have is to email SAT question of the day @gmail.com.
SAT math question of the day @gmail.com.
Yeah.
We only do math here.
Oh, only math questions.
Only math.
Yes.
So it's SAT math question of the day @gmail.com.
Yeah.
Okay, everyone. Have a great day, and have a great day. Okay. Bye-bye.